Good morning, everyone.
Hey, good morning, Praveen.
Hi.
Hi.
Uh, can you see the screen?
Yep.
Oh,
Yes.
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 Okay. So, as I said in the chat, like I see that we are going a little slow, so we'll try to go a little fast, and we'll also try to do some longer duration classes, like sometimes 2 and 2.5 or something like that. We'll try to do longer. Tomorrow we'll try to do 9 to 11:30 or 12. Okay, that kind of we'll try that. Anyways, so today we are going to learn about traversals, the tree traversal mostly. Why are we learning this? First of all, there are few basic tree traversals we should know about, and those are what these are. These are our uh, so this is pre-order, post-order, in order. These are basic tree traversals which everyone should know. Apart from those basic, there are multiple other ways to traverse a tree. And why do we need traversal? Just like any problem we're solving in a tree, we should be able to traverse so that we can do whatever we want to do while traversing a tree. We have to reach a node, we have to search a node, delete a node, we have to find maximum value in the tree. So for that, we have to first traverse completely, and then only we can find the maximum. Until we traverse completely, how will we find the maximum? Or not, if not completely, until we traverse some part of it, how will we find the maximum? Or how will we delete until we reach a node? So all these are traversals. We have to this is similar to our simple traversal in an array. For I equal to 0 to I equal to n, that is also one of traversals. Just linearly we traverse through the array. So similarly, we have to do that kind of operation in our tree as well. For finding maximum, for finding minimum, for finding the element, for deleting element, searching element, everything we need to do through our uh, yes, Suganya.
Nothing is seen in the screen except a white strip.
Okay. Give me a second.
Yeah, it's okay now.
Okay. Yeah. So as I saying, we will learn about the basic traversal, which is pre-order traversal, post-order traversal, and in-order traversal. So you guys know about that. What is pre-order traversal? Have you heard about these things like pre-order traversal, post-order traversal,
Yes.
and in-order traversal? Have you heard of it?
Yes.
Okay. So yes. Now, if you can just tell, Sonia, if you can just tell, what do you know about these traversal? Then we'll go ahead. What is pre-order traversal?
Pre-order traversal is initially the route will be traversed, then the left side and then the right side.
Okay. Okay. So as a word says, pre-order, we start from the root. We do whatever we want to do at that root, and then we do call recursively for the left side and call recursively for the right side. So traversing means we're going to every node and doing something. So that's what I've written here. If you can you see the method I've written here? Yeah. So this is a pre-order traversal, the code of a pre-order. This is a pseudo code for a pre-order traversal. Okay. So what we have done here is we started from the root. We called some method called do something at the root. This do something can do anything. Not and we can implement this do something. Yeah. Suppose we want to just print. So what we did, I am writing a Ruby code. So Ruby code. So just do something can do anything. Now using that, I did what I want to do at the root, and then I just called my left pre-order on the left node, and I called my pre-order on the right node. And this will end somewhere. Otherwise, this recursive will keep on going, and then we'll have problem. Or if not keep on going, at least it will throw null. So we'll have to handle those null cases. I can handle those, but we're not talking about edge case right now. What I think we should be knowing what pre-order is. The edge case is if root is null, then just return. Don't call recursively or don't do anything. That those edge cases will write later. Now similarly, our post order. Similarly, our post order. I'll try to implement this fast. Post order. So as the word says, post order. So first you call the method or recursively on both the left hand child and right child, and they do do whatever you want to do after that. So this is post order. Simple. Now comes the last, in order. So in order is also on the similar lines, but as the word says, first call recursively on the left side and then do something you want to do at the root and then call recursively on the right side. Okay, this is in order. Simple, everyone? This is very simple to understand?
Yes.
Yes.
Yes. Now, why are we learning this? Let's take one example where you are in the root directory, or in a Linux system, you are in the root directory. How will you calculate the size of all the, or how will you calculate the size of that directory? What is the size of that directory? And what you know is size of the files only. Like if you reach a file, you know the what is size of the file. You have this method file.size which will do. So how will you using this? So what the question is, determine the size of current directory, something like this, right? So given directory, current directory, you have to tell what is the size of this current directory, and what you can use is file.size is available. Okay, for this too. So how will that code look like? Can you think? So this is suppose this is an interview question, and that's it. That's what I've told you. Now what will you say or think or tell me? Yes, go ahead, Nikhil.
Praveen, I didn't understand the question. Can you please repeat?
Okay. So what part you did not understand? What is that you're not getting it?
What is file.size?
What is file? What is directory?
Does it mean the current branch, the left or right?
I'm talking about what is directory. Do you know what is directory in a Linux scene?
Oh, you're talking about that. Okay. Yep. So you're talking about a tree only.
I'm not talking about tree directly. I'm talking about direct. Sorry, I'm not talking about tree directly. I'm talking about this directories in a Linux machine, and then you have files. There are two things: files and directories. So we have this Linux machine, and we're in some folder. I want to determine what is the size of that folder or directory. What is the size of that directory? How will you do that?
Okay, got it. Oh, 1 sec.
Yes. So try to write some code in and try to push me in the chat. Okay. Just write something and push me in the chat. Yes. Anyone? Anything? If you're thinking something, let me know what you're thinking. Otherwise, just write the code.
So determine the size it means, and we have to use some Linux commands kind of thing, or how it is like?
What? Come again?
Determining the size means generally we use some commands in Linux machine.
Yes. So implement that command only. Suppose you have to implement those commands. One command you already have been given is you can do file.size. That will give you the size of the file. Now using this command, you have to implement those commands of Linux only. So whatever command is there in Linux, suppose there is a command called df. What does df do? Check deleter.
Decoding.
So the command what it does is, if you do a df space some directory name, it will calculate the size of that directory. So you have to implement that only. Let me write for you again. So given a directory, and there's a method called df, and we pass it some directory. So what it returns is size in MB, suppose. So this is what you have to implement. Given the directory, you have to tell me what is the size of the directory. And if you're not able to visualize what is directory and all those means, let me draw for you. So we have this folder. So this folder or directory A. This has one directory B. This has one more directory C, and this has one file called small d. This is so capital letters are directory and small letters are, sorry, this is C. Wait. This is suppose C, and this is D, and then one more directory called E. Inside B, suppose we have one more directory called capital D, and then we have capital E. Inside this directory, we have one more file called small f. So what has given is that every size, if you read the file, you can do file.size. Now using this file.size, how will you calculate the size of this A directory? What is the size of this A directory? Got the question?
Yes. Praveen, so it's just, it becomes like a traversal problem only, right?
Tell me the solution. Yes, we'll discuss if it's just traversal or not. Tell me how will you do it.
I have written in the chat. Is it the right process?
Just a minute. So you'll traverse the entire file base. Then once the file I'm searching for is found, I'll calculate the stat command. See, whatever, first of all, Sukanya have written, and even Nikhil, you're trying to say, you should think in terms of code. I've tried to say it repeatedly. Try to think in terms of code. Otherwise, there's no point of just saying this if you're not able to write. Because even if you see the solution, you'll have to write in front of an interviewer to tell him what you're trying to think. So the more you have to give more stress on writing the pseudocode rather than. Second thing, yes, noise coming, please. So second thing is the question. Now the question is you have to find the size of the directory using file.size only. This and you're trying to use stat command. You're not allowed to use these commands. The simple what has been given is use those things only. Is that okay, Sukanya?
Yes, okay.
Yeah. Yes. So go ahead again, people. Using the size command, you have to implement df command. Which what it does is suppose this, I'm just saying, suppose might not or might it might or might not do in reality, but suppose this df does calculate size of the directory. So how will you do? Yes, anyone has written anything?
I have just.
Yes.
Yeah.
Santosh?
Adjacent.
Yes. So there is something implemented by Santosh. Let's check that. So find size of the root directory. You're written over here, which is okay, not a problem. If root is equal to null, then contains no something like we have reached the end of the. If root is equal to null, then we to 0. Otherwise, written 1 plus find the size of root dot left, find the size of root dot right. So you were again, I don't know how you thought about this, but on the right path, but not exactly. I don't know why you're simply doing 1 plus find this when you can do something better. Why are you doing this? 1 plus left and right. So Santosh, why this 1?
That root we have to consider, no, that root folder, A
What?
folder, root folder, A directory also we have to consider the size.
Okay. But what will this give? Will this give the size of the directory?
I'm not sure. I thought.
So where have you used this file.size command? So if you reach a file, you should be using that file.size to get the size, na? Where have you done that thing? Can you handle that edge case as well? Instead of simply doing generic edge case of if root equal to null, that is generic edge case which works everywhere in the world. But this is a special question, so think about that special thing. This is a special question where your last node is a leaf, okay, and that leaf node is a file. So what will you do? So think of that. What will that terminating condition be? This is generic root, generic null and all. It's not, and this is one like say we are trying to count a word. Will this give count? It might give you a count, but who cares about the count? I'm not worried about the count. I'm worried about the size of the directory. So forget about the code and come back to size of this directory. What is the size of this directory? By the way, if suppose the size of this file is, let me again get back. Yeah, suppose the file of this size of this file is suppose 20 MB. Size of this file is about 10 MB. Size of this file F is about 30 MB. Okay, and size of we have to calculate size of A. What is the size of A? What will the size of A be equal to? So size of A will be equal to size of this plus this plus this plus this. Won't it be?
Yes.
Yes. So this will be size of 10 plus 20 plus this will be equal to 30. So total will be this total size of this directory will be equal to 60. So that's what we have to calculate. What is the size of this? Now suppose what we do is we are okay. That's the only part we have to do. So that size of A is equal to 60. You have to calculate that thing. How will you calculate now? Suganya?
Yes.
So anything, have you written something? Nikhil? What is the problem? What are the problem you're facing? What is that you're not able to think?
How will I search the node file first? Calculating is easy. I can add the nodes, root, left, and right.
Got it. Okay. So where is that method? So just a minute. This file size starts from a node, suppose root node. Okay, this is root node. Now, when I reach a node, it will have some children. We have some directory children and some file children. People, mute yourself if you are not speaking. Yes. So where we yeah. So every time you go to a node or a directory, or either it will have a then one more thing, either it will be a file, it will be a file itself, or it will be a directory with, or it will be a directory with some directory and some file. Okay, there are two things possible at every node. There are two things possible. One is that it itself is a file, or second that it's not a file but it's a directory with some more directory as children or some more file as children. These are the only two things possible. So that's what we have to write, implement. So if node dot type equal to file, suppose, then what we do, and if else what we do. So what do you do? Return when it is file only. What do you return?
You return the size file.
Simple. You just return the file size. That's it. Nothing else. Otherwise, if it's a directory, what you do is you have to
traversal.
yes.
You do a traversal. You keep on traversing from the left, right, and root.
Okay. Children is equal to root dot children. Just a minute. So there will be multiple children. Children is equal to root dot children. So we just return yeah. So if you see this, if the right now current node, this is instead node, this is root node. If the root dot type is equal to file, then just return the size of the file. That's it, nothing else. Otherwise you take all the child and call recursively for all the child. Once you have called for all of them, you do a summation of all of them and return the output. Okay, so this is little bit not very simple to understand as compared to post order traversal, but this is a post order traversal. Can you see how it is a post order traversal? Let me change this code. Let me change this same code for a binary tree only. This is a code for n-ary tree, like it has n children. That's why I had to do this this root child for child in root dot children, for all the child in this root dot children we have to do. I'll try to write this for a binary tree only and not for n-ary tree. Then it will be simpler for you to understand. If root dot type is equal to file, return file size, and then left size is equal to find size for root dot left, and right size is equal to find size for root dot right. Using these two values, return, or let's calculate first, total size equal to left plus right. I'm writing it unnecessarily so that you understand what is going to happen. And then return this total size. So with this is a, sorry. There is one more condition we can write for null also. If root equal to null. Then run 0. Okay, now if you see this code, this is the same thing for a binary tree. First call on the left subchild, then call on the right child, and they then do the calculation for the from both the children, value of both the children, and then return that. So this is a way to calculate size. Will this work, everyone? Suganya, will this work?
But we are not calculating the root size here.
We are calculating the size of the. I don't understand. What are you asking?
Right and left.
Yes, we are calculating right or left, and then using that to calculate the current size. Or you can
then
say.
For the root,
yes.
For the root also we have to consider the size, no?
Yes, you might want to consider like every directory itself has a size of 4 KB, something like that. Then you can say, okay, root dot. So just like if it is not a file, it's a directory. Then directory dot size also equal to 4 KB only. So let's suppose that every directory is just 4 KB. 4 KB plus size of the left subtree and right subtree. Is that okay now?
Yes.
So, an empty directory is suppose assuming 4 KB something like that. Then is that okay now?
Yes.
Yeah. So do you see what kind of traversal are you doing here? What are traversal we are doing here?
Post order.
Post order, is that clear from this code that this is post order?
Yes.
So we first traverse the left subtree, then we traverse the right subtree, and then using the output of those two, we calculate the size of the current directory and then return that. So this is a post order. So we'll be, while solving a lot of questions, we'll be using this post and pre-order, and without even knowing that we are doing this post and pre-order. Okay?
Okay.
Yes. So that is the example of post order. Now we will go ahead and try to do this. So all these traversal use recursive method. Very simple recursion. It was very easy to write. It was very easy to understand. Okay. It was very easy to write and understand because it's a very simple code. 2-3 lines of code. One do something, then recursive one, then recursion 1 and recursion 2. Very simple to understand with some edge cases when to stop. Now I take an interview question. The interview question is: do the traversal, same pre or traversal, but without recursion. So the recursion, the pre-order which we wrote, this was a recursive method. Why recursive? Because it called itself twice. Even if it called once only, it would have been enough to call it recursive method. So it called itself twice, and this is a recursive method. But there's a question. There's an interview question which says: do a pre or traversal of a tree, like visit all the nodes of a tree without recursion. You're not allowed to use recursion. You can do anything else, any kind of iteration you can do. You can use anything you want, but do not use a recursive method. Do you get the question?
Yes.
Okay. If you have something in your mind, start thinking. Otherwise, you can ask me any doubt you want, so I can help you start thinking only.
Praveen, you can use a stack.
Okay, and why do you think you want to use a stack?
Because you can pop it. You said without recursion, so I thought you can pop the elements like the left child or right child and root and get them as you're moving, meaning going towards the end.
Okay. Can you try to write? So everyone heard him. So can you try on the similar lines? Can you try to write the code? So he he want to use a stack. Okay. Now Nikhil says that he want to use a stack to do this pre-order traversal. So now that's your hint. You can use a stack. You can push and pop element from that stack to implement the order we want. So let me just draw a tree for you, so that you can keep on thinking parallelly about what we are trying. Let me see if I can draw a tree for you. I'll draw manually. So this is a tree. Okay, can you see this tree? Before you write the non-recursive code, the iterative code for this, what will the pre-order be? Can someone tell me? I'll write here. What is the pre-order going to be?
5.
So by pre-order, okay, 5 will so pre-order traversal we are trying to print. Okay, 5. Okay, then
2.
Okay. Then
1. It should be 1 or 9?
1 or 9. That's what you think. So we start. Suppose this do something is print root. Okay. Let me.
It should be 1.
This. So let me change this. So this is what we're doing is we're printing print root dot. What we're doing now. Think what will happen. So we called first on the 5. It first printed 5. Okay. And then called on 2 and 9. Okay. 2 and 9, both of them. When I called 2, it first printed 2 and then called on 1 and 4. So when I again recursively I thinking that it will call for this 1. So 5 and then 2 and then 1. What will be printed after 1?
4, 3.
Then we print 4. Okay, and then
3.
Okay. After that
9.
now we'll go to 9. Yes, and we'll call recursively on 7 and 11. Then what will print?
7, 6, 8.
7, 6, 8.
And 11, 10.
11 and 10. Great. So this is a pre-order traversal. Can you, Nikhil, tell me the post-order traversal of this?
Yeah, sure. Yeah, sure.
Right. Tell me what was the post-order looking like.
So 1,
Just to give
3.
Yeah.
Yep.
1 and then
1, 3, 4.
Okay.
2.
1, 3, 4, 2.
Then you go to the right subtree. Then you go to 6.
6.
8.
8.
7.
7.
Then you go to 10, 11. 9, 5.
Correct. Santosh, in order. Santosh, in order traversal, tell me. Santosh, are you speaking or you
Yes,
can't
yes.
listen to you? Yeah.
Unable to.
Are you saying or not? Like in order traversal, I'm asking.
I'm thinking actually.
Okay. So what is
Should be
in order
one.
traversal? We call in order on 5. What it does, it first it calls in order on the left subchild, and then it prints 5, and then it calls it in order right subchild. So let's start with 5. It calls for left and right, and then so it will call for left. So again, we'll be on 2. It will call for 1, and then it will call for it will print itself, and then only it will go to right. So let's go to the left subchild. Again, on the left, we have only 1. 1 will call on the left, then nothing. It will come back. Then it will print itself 1. So first thing will be 1. After that, it will print the right child. Then nothing on the right, so go away, done. Then it will try to go up where it was called from, and it will print that 2. Okay, then it will print 2. So after that, it will go in the right subchild. Again, in the right subchild, it was called 4. 4 will not print itself. So it will first call on the left, which will print 3, and then it will print itself 4, and then try to call recursively on the right subchild. There is no subchild, done. We'll come back. So now we go back to 5. So 5 had called for 2. 2 is done, and then I will try to print myself. I printed 5. Now 5, after printing myself, I will call the left and on the right side. So I called on 9. 9 will call on the left. That means it calls for 7. 7 will call for 6. So 6 is called, and 6 will be printed, and then 6 will be done. So we'll go up, and then we just print itself. 7 is printed, and then 7 will call for right. So right will do same printing of right will also do same printing of 8, and then come back. Sorry, yeah, we're done with the left subchild of 9. So we'll print 9 now. Now we have printed 9. We go to right subchild of right child of 7. 9. 9 will call on 11. 11 will call on 10. So we'll print 10, and then come back and print 11. There's nothing on the right of 11. So done.
Okay.
Done. So if you try to look at this in order traversal, how does it look like? So what we do is we start from the root. We cover every node from the left side first. Then we cover the node from the bottom side, and then we cover the node from the right side. Again, this 2 we had already covered from the left side. Now we are covering this node from bottom side, and then we'll cover it from again right to sometime later. After that, we go to 4. 4 we covering from left side. We going down. We covering 3 from left side. We are covering 3 from bottom side, and then we covering 4 from right side. Coming back, we are covering our 4 from right side also now. So bottom side and right side at the same time. For 2, we had already covered from left and right bottom. Now we're covering from right, so we're going up. And then 5, we had already covered from left side. Now we're covering it from bottom side, and then going on the left side. So it looks like a traversal where we're covering each node thrice. One not covering, but we're going through a node every thrice. One is from the left side, one is from the bottom, and then we one from the right side. So this is the right inward traversal. Okay. So if you try to take a look, your pre-order traversal is very having good property. Can you notice what is the special about this pre-order traversal? Sorry, inward traversal. What is the special thing about this inward traversal?
Sorted.
Yes. So it would be sorted if your binary tree was a binary search tree. If your tree was a binary search tree, a spatial binary tree, which is binary search tree, then if you do an inner traversal of a binary search tree, if you do an inner traversal of BST, then your order, the inner traversal will be sorted. Okay. So this is sometimes used also somewhere. Suppose if I ask you a question, given a binary search tree, can you sort it? So just one line answer can be, yes, I'll do an in order traversal and I'll get the sorted order of all. Okay.
Okay.
Yeah. So now coming back to our main question, sorry. So coming back to the main question, which is you have to write a code for pre-order traversal. You have to do pre-order traversal. You have to print this order, which we have written here. You have to print this order, but without using recursion. And according to Nikhil, that you would like to use a stack. So you're okay to use. 1 minute, just give me a second.
दो दिन क्योंकि वो बिल्डिंग का प्रोजेक्टर आ जाएगा ना तो
ठीक है
कभी भी शिफ्ट कर सकते हो.
Yes, so again I'll give you 2 more minutes. Okay, so people have written something. Let me chat. So the chat. What is this, Sukanya? What are you trying to do? Hello.
Yes, Praveen.
Nothing. You
Stack
try
is,
to. Yes.
but Nikhil said we can do that stack.
What I didn't get, come again?
What Nikhil said that using stack we have to implement it without recursion.
Without?
Without recursion, if we have to do, we have to use one stack.
Yes. So is that a problem?
No. So, but using a third data structure,
Yes.
will that create an issue with time and space?
Yes, it will. So the most important thing is solution, and the second thing is your complexity and everything. So until you solve something, don't worry about the efficiency. Okay, most important part is solution and not your efficiency. So every time just think about the solution first, and then only once you have solution, then we'll talk about efficiency, and then we'll talk about the edge cases. Okay, never try to think about edge cases and then those initially only. It will just waste your time. Okay.
Okay.
Yeah.
We can use a structure also.
What do you mean by structure?
Means these nodes, like in linked list, we do track node.
Yeah, you can use. You can use.
And then we will keep on pushing in the node right and node left and node root, we will keep on pushing the data.
Where do you push?
But for that also we need a stack.
Yeah, so use the stack. I'm okay with using a stack. Okay. So given I'll give you 2 more minutes. I'm muting myself. I'll be back in 2 minutes. Try to write something. Yes. Do we have something? Santosh?
Yes.
Hello? Yeah.
Yes, sir.
Yeah. So, anything are you able to write something? Otherwise, just say whatever you start, wherever you start, tell me so that I can unblock you your thinking. Tell me what you're not able to think.
Yeah, I'm writing some code actually.
Okay, take your time.
Actually, I got stuck somewhere like how to go back to the right node. Um,
Okay. Yes, so this is the code you have written. You first initialize a stack, empty stack of nodes. Then while root is not equal to null, you keep on pushing into the stack and then do a root equal to root dot left. So you push everything. Okay, and then what? Then we haven't done much. Okay, so you push everything into the stack and you did not use it back. You should use it back as well, nah? Like if you're pushing something, why don't you pop up and then reuse somewhere? So you have your empty stack. You push your root into that, and then you then you went to left. You first of all you haven't even touched the right. So in pre-order, what we do is we at least touch the left and right ones. So left node is equal to root dot left, and right node is equal to right dot left. Okay. Now we have these two. We haven't written a recursion, but we have picked up both the right and left child. Okay. So Nikhil, can you mix and write at? Okay, you written. Right. We'll talk about your code also later. So yes, Santosh. So what I'm saying is, you have pushed your root. That is good. But and you have your left and right. What will you do with that? So I'm drawing a stack. This is a stack of nodes. So, Nikhil, I'll come to your code. Now, Santosh, everyone try to concentrate here. We have this tree with the root node 4, and then we have an empty stack. We want to implement our pre-order using this. So what does pre-order means? First, what should print is 4, and then what we should print is 2, and then 1, and then 3, and then 6, and then 5, and then 7. That is the order in which we want to print. So what we can do is we can push 4 into this 4 here. We have pushed node 4, and then we want to not push 4. Let's talk about we will push 4, but later will. So what we do is we want to get an order in which 4 will come first, and then 2 will come later, and then 6 will come after that. So in what order should they be? In what order should 4, 2, and 6 be in the stack, so that we can pop it out, and then order will be. So if it was like this, 4, and then it was 2 was there, and then 6. Suppose if this was the case, suppose somehow if we inserted our elements in this order, 4, 6, 2, and 6, 4, 2, and 6, then if we pop it out, the order will be first 4 will come, then 2 will come, and then 6 will come. Suppose this was our this is just this. Suppose this part was our tree, only 4, 2, and 6. The order, what is pre-order of that 4, 2, and 6? Santosh?
Yes.
So the pre-order of 4, 2, and 6, 4, and then 2, and then 6. So if we somehow insert in this order, we could have just popped out in this order, and we'll get the order we want. So our aim is something like push in this order, in the order which we want. That kind of order we have to push. So now I'm coming back. So we might not be able to push everything, and then we might not do pop at once. We'll keep on doing intermittently, like okay, push and pop and together. So let's start from a first value. I'll give just push 4. Okay, just push 4 here, first root node, and then you can do a push and a pop. Now you can perform both. Okay, you are at the right child, you are at the node, and you have pushed one of them, and now you have the power to go to left child, right child, and you have to also can do push and pop and everything. So what would you like to do? So first, so that you get the order you want. You want 4 first, then you want 2, and then you want 1. So okay, then you want 1. Now so what order should you pop and push so that you get this properly? And the order we want matter is the order in which you're popping. Okay, so there's one thing happening every time continuously. We are doing pushing, but that pushing order we don't care a lot. What we care is in the order simultaneously we are also doing pop. So the order in which we are popping is the order we will be using. So we pushed first, nothing is printed. Okay, we pushed 4 here, we pushed 4 here, nothing is printed. But then what I did was I will pop whatever is the topmost element from the root, topmost element from the stack. I'll pop it out and print that, and after that I'll push the other 2 children inside inside this stack. So what I'll do is I'll push 6 and I'll push 2, this order. Now what I'll do is I'll push again from the topmost. I'll push 2 and print 2, and I'll push a child of 2 into the stack. So what is child of 2? That is, I'll push 3 and 1. First I'll push 3, and then I'll push 1. Why I'm doing this? Even in the first case, I push 6 first, and then 2 on top of that. Now I'm pushing child of 2. First I'll push child 3, and then I'll push child 1. Okay, that order will push into it. Now again I'll pop the topmost element, which is 1, obviously, which will be 1, and then I'll try to push the child of 1. There's no child, so done. We'll go ahead. Then I'll pop 3. Again, no child, done. We don't have to do anything. Then I'll pop 6. So 6 I have popped. Let me delete everything now. We have popped 1, we have popped 3, and we have popped 6. Now the moment we popped 6, we have our child 5 and child 7, and we'll push 7 into it, and we'll push 5 also. Now we come back. I will pop the head of this. We print that, and then we push the children of 5. The no children 5 done. So we go and pop the next element. So we pop 7. No children of 7. We don't have to push anything. Done. This is the order we wanted. 4, 2, 1, 3, 6, 5, 7. Is this correct?
Yes.
So now do you have idea what we are doing? And now can you try to write the loop or yeah, iterative method using whatever we did right now? Can you just write whatever just told?
Okay.
So I'll try to write something for you so that you can just complete that. So we have to do iterative pre-order of the root node from the root node, and if so first let's initialize the stack. Stack s equal to new stack stack of nodes you want to write. You can write that as well. And what we do is first the starting only the moment we start only s dot push will first push the first child initially only. The moment we have pushed, we can go ahead and implement our full loop, full iterative loop, while root is not null. Oh, sorry, not this. While stack is not empty. So this is important thing. What is this I'm trying to write? Is empty, something like this. So while this s stack is empty or not empty, till that point I keep on doing the loop, keep on popping. Okay, till that point of time, keep on popping. Now, if you pop without pushing, then it will be empty in the next loop only. So we have to push also. Okay, this is the code I've written. Now you have to complete this. This is almost complete. What I'm doing, and then I push the first root, I push the first node, and then I ran a loop, while loop. What it does, it just keep on popping everything, and then printing also. So let me write one more part of it. Print as dot pop. I'm doing this for printing also. So what else is left? What else? What are the other lines? Just you have to write. Just write fast, okay? Nikhil, you had given some solution. Try to use that here only and try to write the lines which are not written. What else you'll do?
Yes, Praveen.
Yes. Now, why are you taking so much time to think? What is the point we have to write, missing here? What is the, you have to write?
If s dot right is not equal to null, we just have to push it, push the right.
So don't say random things. I really don't like people. What is s dot right? What s is stack? What is stack dot right? S is stack. Is there something called write method in stack?
Oh no.
Praveen, root dot right is not equal to null, then s dot push of root dot right
If root dot right
is not equal to null,
is not equal to null, then what?
then s dot push of root dot right.
S dot push of root dot right.
Yes.
And otherwise, or
And else root dot left is not equal to null, s dot push of root dot left.
is this correct? And then after that, you want to pop also?
Yes.
So we have Is this correct, Sukanya?
Yes, Praveen.
Okay, so you are running this loop. Where are we changing the route here? Every time we'll do the same thing, root dot right and then null. And are we changing route anywhere?
Yes, once we are traveling to the right, and no, we are not changing the route.
So will this work? Like you started with a root node, you push that into the tree, and then you do the while loop. Every time check if right equal to null, right or if right equal to null, and left equal to null.
No, we can do the route as S and then S plus plus because we have to move to the next route.
So root, it won't be a root. What you want to do is, I want to check for the topmost every time. What topmost element? Top element in the stack.
Yes,
Top
yes,
element
top.
in the stack. This whatever we want to do is we want to do for topmost element. Top element of the stack. So it will take S dot top.
Yep, you'll peek or correct.
And then do this right check and left check on that node, not on the root every time. Root to start kiya tha humne just. We started with the root, but we are now pushing everything into the stack and popping it, and before popping, just making sure that its children has been pushed.
Okay.
Is this correct now?
Yes.
So now try to think, will this work? Will this do pre-order properly? So if the way we draw the diagram, the previous one, where we had a tree and the stack, we first will push the root node, and then we'll keep on popping. And while popping, we also push also. So at the end, unless everything is unless the stack is empty, we'll keep on running this while loop. And what it does, it takes the topmost element, pushes the right child into the first, and then pushes the left child into the tree, into the stack, and then just pop the current element, and then again go back and check whatever is at the top. Use that again. Okay, done. Correct.
Yes.
Okay. So now your assignment is, someone note it down and then try to paste in the doc. Assignment is iterative, in order and post order. Okay, these are the two assignments you have to think about. How will you do an iterative in order traversal and iterative post order traversal, both of them. Can you try?
Yep.
Santosh, can you think of solution right now? Do you want me to explain anything, or you will be trying at your home, like after class?
I will try.
Yes, you can try and don't miss. At least implement one of them. If not both, just implement one of them. If you have any question, try to ask on the WhatsApp chat. Keep on talking. The more you talk, the more you'll be involved. The more you don't expect me to ping every time, and you just skip 5 days. I'm sure you're not spending a lot of time during this 5 days of break. But I say try to be in touch with questions and try to keep up pinging. That's the only way you can be in touch. At least if one of you only just pings once or twice a day, all of you will be in touch rather than spending time without doing anything for 5 days. It will be better if you try to be in touch in the class in the 5 days of the week and discuss something that will keep your mind fresh and also keep your mind thought process aligned. Otherwise, you won't get the benefits as much as you can by keeping in touch every day. Okay, so I try to do it, but it's your duty. You should be doing it. Just ask any question and anyone will answer. Obviously, I'm the one who will be answering a lot, but you people also, if you have time, try to ask, and if you have time, try to answer. But try to make this keep this group active. Okay, every day.
Okay.
And then that will be very fruitful. All of you at least discover 1-2 questions every day, not more than that. Just 1 question every day, just 2 questions every day, and that will make 6 questions every day, and that will be like best practice you can have rather than all these classes. Done. Okay. So now coming to the next part is, suppose tree traversal has been given. Okay, suppose we have a tree traversal already given, something like this. This is the order in which roots were printed, nodes were printed. and this when I traverse in the pre-order. The point is, suppose there was already a pre-order given, which was this pre-order, and we want to draw the tree. Can we draw the tree using the data we have? Can you tell me what are the which is the root node, which is the left node, which is of that root, which is the right node of that root? Can you draw the complete tree using this traversal? Do you understand the question? Given the traversal, given the order of the nodes, when we traversed this tree, this is the order it was printed. So, given this order, and we know this is a pre-order, can you determine the original tree? Is it possible? First of all,
Yes.
Okay. So, forget about the algorithm. Just tell me, what do you think the root was?
1 is the root.
1 was the root. Everyone agrees on that point?
Yes.
Yes. What was the left child?
2.
You're saying 2 was the left child? Okay. And what was the right child?
Right child of 1 or right child of 2?
Tell me anything. What do you think is right child of 2, and what do you think is right child of 1? Tell me anything.
2, then 3, 4. 3 is left, 4 is right.
3 is the left side of
2.
2.
3 is the left side of 2. Okay. And then Nikhil?
4 is the right child of 2.
No.
4 is the right child of 2. Okay. And then
5 is the right child of 4.
5 is the right child of 2.
4.
5 is the right child of 4.
And
Okay,
then 6 is the right child of 1.
6 is the right child of 1. Anyone? Do you think this is right or wrong?
I
6 is the right
think
child,
it's
correct?
wrong.
Wrong.
I don't think.
Where's the right child? Where's the 6? I don't want to say it myself, but I want you to come up with something. Like the question was, can we or not? You're trying to drop. Have you observed anything right till now? What is happening? Can you draw? Yes.
We have to also check that each level it is height balanced and all.
Why do you want to check that? Why do you want to do unnecessary things when I'm not asking you to? So that's the problem again. So I think this is a problem you'll be facing a lot. If you not concentrate on the main problem, try to go in random directions. Of course, you have to think a lot of things, but these things will just divert your main thought. Why would you include height, balance, and all things? Okay, so those are different things. I understand it's difficult for you right now to think what is needed or not. You try to think in all the direction, but this is not needed right now. The height balance thing. You simply for pre-order and post-order, you don't have to make sure this is height balanced or not. So these things you'll have to improve a little bit. Anyways, let's go ahead. So you're saying 6 will be right child of 1. After that, 7. Where will 7 go?
Left of 6.
Left of 6, and then 8.
Praveen, I just wanted to correct myself again. So I think every child goes left side only till the complete left side. From
There's
1
no
to
noise coming. Can you either mute yourself or make the sure there's no noise? Kahan se aa raha noise? Okay. Now, yes, Santosh, go ahead. You're doing something, and make sure there's no noise from the background. Santosh? Okay, not audible. This means you have muted yourself.
Praveen.
Yes, go ahead. You're saying something.
I think every node is left side of everything. So they won't be right actually. I thought completely left side till last. Yeah, like that.
1, 2, 3,
4 right. Yes,
Okay, so you're saying this is correct?
I think yes.
Okay. And Sukanya, can you complete your solution? 7 is here, and then where will 8 go?
Right of 6
Right of 6, 8. Okay, after that.
and right of 8 is 9.
Okay. Nikhil, do you also have something in your mind?
Sukanyas, I think because
Okay.
you're keeping it in mind. So
Yes. So if you haven't observed till now, these are not the only two options. These are both of them are the correct tree. Both of them will have the same output if you do a pre-order traversal. Your tree, Santosh, even if you do a pre-order, it will return the same thing. What Sukanya's tree will return. My point, I wanted you to observe yourself first. It's not there's no unique tree which will have this only pre-order. It is ambiguous. We don't know which tree created this. There can be multiple options which ended up creating same pre-order. Hence, my question was: can we determine a unique tree? Can we determine a tree using our given pre-order? So answer is no, we cannot. Why? Because there are multiple options can lead to same pre-order. There are multiple trees which have same pre-order. So we cannot uniquely identify the tree. There will be more than exponential number of options for the same, not just two, but there will be lots of options which have same pre-order. Hence, we cannot determine uniquely. Do you get that now?
Yes.
I wanted you to understand this yourself. So let me draw one more example. Even that will have same pre-order. 1 and then only right side. 2, 3, 4, 5. Even this will have same pre-order. No, correct?
Yes.
Yes. So
Praveen, but these
even
are skewed. Oh,
what?
but this is a skewed tree, no? Meaning it does not. It is just having on one direction.
So you should not add the word but. This is nice that you notice a skew tree. What is the problem with skew tree? But this is skew. What is the problem if it is skew tree? Is that the problem with this question? Can we not talk about skew tree? You notice it. It's good that you notice this is skew tree. But again, my point is this. I'm noticing a lot that you people think these things telling about skew tree and that will be a problem. Using a stack will be a problem. Uh, uh, do we have to maintain height balance? So those things are good to notice, but not everything should be inserted everywhere else. That happens in interviews. People try to there are cases when I've seen people try to insert something which is not needed and then just we'll do divide and conquer. We'll do divide and conquer. I've seen this sometimes happening in our interviews. So try to avoid this. This is very much important. Otherwise, in the first impression, only interviewer, okay, this person has less idea of the things what he's saying about, and he's randomly trying multiple things. Even though you're not trying, you're just trying to notice your few things which you have learned, and you come up with those words, and it looks like as if you're thinking that thing. Although you might not be thinking. You're not thinking on the lines of skew tree. We'll do something else. You might not be thinking, but you just remember skew tree and you spoke about it. That will cost you a negative point. If that doesn't matter, if it matters, of course that will be okay. That is not a problem. If it doesn't matter and you're trying multiple random things and that too loudly and with the in mind and that too like I can hear and I mean you're trying it as a solution. Just naming it, that's okay. Okay, this is skewed tree and asking you a question. Do you think I have to differentiate between a skewed tree and a binary tree and normal binary tree? Then it's okay. But try to avoid this. Okay, I'm not repeating that anymore. So you should be not including everything when it is not needed. चलो अब आगे बढ़ते हैं. My point was we cannot determine a tree uniquely. I'll do one more tree which will have same pre-order 1 and then 2 on the right side and then 3 this is 2 then this is 3 and then this is 4 and then 5 somewhere, 6 somewhere, 7 somewhere, 8 somewhere. So this tree will also have same pre-order 1, 2, 3, 4, 5, 6. Is it correct?
Yeah.
So there are multiple trees which will have same pre-order. Hence we cannot determine. I have drawn so many examples, and you should be okay with this now. How the point that we cannot draw it. Now I have changed the question now. Given pre-order as well as in order, both of them have been given to you. Not just the pre-order, but Let me change your pre-order first of a little bit. Suppose this was in order only, and let me change the in order. So 5, and then I had. Let's draw the tree first. This will be easy for me to give you example. So we have this node 5. So this is the question now. Given the pre-order as well as in order, this is the given pre-order and this is the given in order. Can we determine our tree uniquely now? We have been given both of them, not just one of them, but both pre-order and in order. Can we determine the tree now?
Yes, we can try, because now we can understand which is the root and which is the left, right.
Nice. So try that now. Can you talk about what we'll do, and then we'll write the code later.
5 is the root.
Okay, let me draw that for you. Just a second. So 5 will be the root. Now what?
1 will be on its right, left child.
1 will be the left child. Okay.
1. Sorry, it's 3.
3 will be the left child.
Yeah. 1,
Okay.
3. Oh no, 1. 1 and 3. 1 and then right side will be 3.
1 will be the left child.
Yes, yes.
And right side will be
3.
okay. Santosh and Nikhil, you keep follow this. Yes. After that,
4 will be also this side only, but
okay. Take your time, think,
yes.
and try. If you're everything good, otherwise think on the lines I'm going to tell now. So when you had a pre-order, you started the first node is the root. For sure, you know that.
Yes.
But then you do not know the rest of the array, the rest of the pre-order, which part will go on the left side of this and which part will go on the right side of this. So my point is, in the pre-order, 5 is the root, and some of them goes on the left side and some of them goes on the right side. But which one goes on the left and which one goes on the right? That was a confusion. Okay, understand? So whatever the pre-order was, this is for sure that the first will be the root, and then there will be some part which will go on the left of this 5, and there will be some part will go on the right side of the 5. This is thing you have to analyze. That your pre-order, the way it has been showed is 5 will be the first, will be the root node, and then some part of it will be on the left side of 5, and some part of it will be on the right side. But that, where is that line which says which part will be on the left and which part will be on the right? That line is the confusion in the only pre-order. But now we have our in order. We should be able to use our in order to determine what part will be on the left side, what part will be on the right side. Do you get my hint?
Yes, yes.
Now use
So
that.
we have to identify the root node in order, that is 5.
Yes.
Oh.
So from the left side of the root node is left side and right side of that root node is right side.
Great. So what you have done is, with the help of in order, I determined, okay, everything on the left of 5 will be the left part of the 5, and everything on the right will be right part of the 5. Now we have this and this separated. So we have one level problem solved. So we have 5 in our root, and we just know that all 3 of them, which is like this 3, 1, 4, the pre-order 3, pre-order 1, and pre-order 4, with in order 1, with in order 4. This will on the right. All these will go on the right, left side, and then all this, the pre-order of 8, 7, and 9, and the in order is 7, 8, and 9. This will go on the right side. Now we have to determine the full tree. So what is the next step?
3 should be 3 and 1, and 4 should be somewhere down.
Santosh, what we'll do? So we have our root decided. We have left node decided. Not we have left subtree decided, but not the left node. I don't know what left node, but I have just decided that this 3, 1, 4 and 3, 1, 4 will go on the left side, but whether 3 or 1 or 4, that also we have to decide. And similarly on the right side, we know all 8, 7, 9 will go, but which will be the root, and we haven't yet decided. So we have to talk about
We can
this
say
thing.
we can
Yes?
say 3 is the root. We can say 3 is the root on the left side.
Okay, and how do you say that?
In the pre-order,
Because
root next node is 3.
yeah, in correct. And in pre-order, root comes first, and in order, root comes in the middle.
Okay, so now your problem was reduced to a smaller sub problem, which is now we have to just determine about this 314, what that 314 construct. Earlier it was 5, 3, 1, 4, 8, 7, 9, the full tree. Now our problem is reduced to very small, so half of the only problem, which is just determine the root of 314 and 134. And you're saying because the pre-order is 314, because the pre-order is 314, hence 3 will be the root node of this part. So 3 will be root node, and rest 1 and 4 will be either on the left or right. So now we determine what will go on the left and what will go on the right. Same logic will apply. If for 314, 3 is the root, then what part of will go on the right and what part will go on the right? That will define where the 3 is here. So left part is just 1. 1 will go on to the left side and 4 will go on to the right side. Is this correct?
Yes.
Now we do not have any more subtree left, so we'll just end up here. Similarly, we'll do it same thing for our right side of the tree. What we'll do is we will have to, from this 8, 7 and 9, we have to determine what will the root be. What will the root be?
8.
So you're saying 8 will be the root. Why 8 will be the root, Sukanya?
Because the in order is telling 7, 8, 9. So 8 must be the root.
No, why 8, again your statement, why 8 will be root?
In pre-order also we are saying 8 at the beginning, and in order 8 in the middle.
Not also. In pre-order, 8 is the first, hence it will be the root. Pre-order mein wo kahan pe hai, that is not a determined factor. The determined factor is 8 is the first element of the pre-order, and hence 8 will be the root. That's it. Okay. Now with that root decided, we have to decide what is the left and right side child. So now comes the use of pre-order, in order. So using this in order will tell what will go on the left side, what will go on the right side.
7 on the left and 9 on the right.
Yes. So pre-order was used to determine the root, and in order is used to determine the left and right subtree. Correct?
Yes.
So is there any other way we can consider the tree, or this is the only tree possible?
This is the unit tree way possible.
Nice. So this is the only tree possible. With this, both of them given, pre-order and in order, both the traversal given, we can determine our tree uniquely. Okay.
Yes.
So shall we write the code?
Yeah.
Let's write some code. So we have array which stores the pre-order, and we have another array which is storing the in order, and we want to create our tree and then return the root of the tree. So let's write a return type of node and then create binary tree using this pre-order traversal array, using post order traversal, sorry, not post, in order traversal array, using these two. This is signature method. People try to write this, even I am writing parallelly. Okay, so try to write what are the things you want to do. So first I create my root node. Node root is equal to new node, and the value of that will be pre-order ka first, pre-order 0th element. Is it correct? The first node will do this, and then people, is it correct?
Yeah.
Yeah. So and then we'll call recursively. Now we have to call recursively, and that recursion will return me the root of the left subchild and root of the right subchild. So left root will be returned by the recursive call. Left root will be returned by one recursive call, and right root will be returned by right recursive call. Now we have to determine what that recursive call is going to be. What will change in this recursion call? Because So we call this recursive twice, and then once we have both of them calculated, what we'll just do is we'll mark our root dot left equal to the left subtree, and then root dot right is equal to right subtree. We have done both the things. So now the only part remaining here is how will we call this recursion? What will change in this recursion? We will call recursively on the left subtree and right subtree. What for the left to create the left subtree and to create the right subtree with the same pre-order, with the same in-order array, but with changed part of it, not the full part of it, but changed part. Do you get the code till now which I've written? Nikhil?
Yes.
Yes, Praveen.
Okay. So tell me what you will pass, or how will you change your pre-order in order? What you will change? Will you change the array? Will you change something else? Or
I think we
now you
should
get
change the
the
indexing.
Yes.
We should change the indexing.
Yes, correct. So we have to change the index now. Where will the pre-order start and where will the in-order start, something like that. So initially it was full array, so we just passed full array. But in the next recursive call, we have to change. You can't use the full array anymore. You have to use only this part of the array for pre-order, and only this part of the array for in-order. I could have passed it a complete new array, which I don't want to use unnecessarily so many arrays. So we just change the indexes. So let's write what those indexes are going to be. The index will be int start of the pre-order array and end of the pre-order array. End of the pre-order array. This is one thing we'll pass. Another thing we'll pass start of the in-order array. Start of the in-order array and end of the in-order array. End of the in-order array. So these four things we are passing. So initially when I call them, when I call this, I'll call with pre-order, in-order, and then I'll call this part. I'll call from 0 to n, and then I'll call from 0 to n. Okay, this is what I will start with, and this will call recursively for the rest of the indexes. So what will the new indexes be? Can someone think about the new index for the left subchild and right subchild, depending upon these values? Yes. What I'll pass for the left recursive call, Nikhil. So suppose we are here, we have determined our root. Now the rest part of it will go to the left subchild. This is the new index of the left pre-order, starting from one ahead of the place we just found our root, and then right part of this. This is the right part. Right. This is the left one, is the right part. So this is the start, 3 is the start, and 4 is the end. So what is the index of 3 and what is the index of 4?
So index of 3 will be int of start pre plus 1, and
Nice.
index of end will be n minus 1. Wait, no, sorry, n minus. One sec. 1, 2.
Okay. Before you calculate this, just talk about the in-order start and end. Okay, let's wait for this later. Tell me what will the start of the in-order part of the array? What will the new start for this? So you have your reached 5. You have reached your 5. Where 5 is, and then left part will be will be here, and right part will. So what will be this index? Suppose your int so root will be not 0. I'm writing a generic code now. First we create. Okay, people do not. Can someone who will make making noise, go to mute mode. Okay, so root is created from this pre-order traversal, the first node of the pre-order traversal. So this is the pre-order traversal, this is the first node. So we have created the root. Now this pre-order traversal, wherever it is, it would be somewhere. So we have to find this value. Where is it present in our pre-order? This step is missing. Find this and in our pre-order traversal, in our traversal. So this element we have to find. Wherever that index is, that index we have it here will be used for our next recursive call. For our next recursive call will be from old start, that is start in old start of the in order, from that point to index -1. Index -1. And for the right recursive call, I'm again writing x, y, we'll talk about later. For the right recursive call, it will be index plus 1, comma, the old last index, which was end in. Do you understand this part? The recursive part of changing the index for in order tree, in order array? Sukanya?
Praveen, can you repeat that first recursive, this start 3 plus 1 and all?
Okay, so
Praveen,
huh?
I didn't get the index part. Could you just
Okay.
please repeat that?
Yes. So we have to create our tree using the in-order and pre-order traversal. So this is the array which contains the pre-order. This is the array which contains the in-order. So, and this is the starting index. What part of the array we want to talk about? Starting index and the end index of pre-order array, and the start index and end index of the in-order array. We have both the array. We just wanted to maintain what part we are right now worried about, because we are solving recursively. We will just reduce the problem into sub problem. So we'll keep on changing these values. Okay, that and using those two values only, we'll decide what is our sub problem. So whatever stage we are in at that point of time, our first node of the pre-order, the first node. What is the first node? First node is start of pre. This is the first index. Hence, this will create the root out of this value. We have a pre-order the first element, and that will give our root node. And using this root node, we'll decide for now that we have the root node, we want to determine what is the left, what will go on the left side and what will go on the right side. So that for that decision, first of all, we'll have to find where is that element which you just create a root out of that. Where does that value? This is the value pre-order of the start tree. This is what we created the root from. Whatever root we created, where is that present in our in-order traversal? This is our in-order traversal. Where is that present? So we have to find that thing. So we try to find in our find that in-order array where that exists. So wherever that exists, that index we got it. So for example, we started with this value. So we created node, the root node from 5, and then we tried to find where that 5 is, so that we can determine what is the left subchild and right subchild. That is what it was used for. So this is the just index 4. This will return 0, 1, 2, 3. This will return 3. Your 5, which is the first child in the first node in the pre-order, has the index of 3. So just 3 is returned. Now we have 3 returned, and we have node created. Using these two, you can create our left subtree. Same pre-order, same in order, but this time start. Okay, I'm talking about this part first, which is the new index for the in order. So this in order, initially it was from here to here, start into end in, from 1 to 9. But this time it won't be 1 to 9, it will be 1 to 4 only. So that's 1 to 4. What is 4? This 1 to index of 4, which is 2. So this is index is for 5. We have to run till index of 4 only. So it's index -1. Similarly, the next recursive call for the right subtree, that will be from index se ek aage, from 7, so index +1 till the end, which was same end. So we have passed these two, start into index -1 and index +1 to end. These two we have passed. So to the left call and the right call, but we haven't yet talked how will that pre-order indexes change. So when we talk about this, how will these two change? So in our pre-order, we started from start pre. In the left sub call, we will do it from old index, which was 5 plus 1, from 3 till some number, from 3 till somewhere. I don't know what somewhere, but so starting will be start of pre plus 1. This is clear?
Yes, Praveen.
Okay.
Yes.
So this is okay. So this will be from 3 till some point of time. What is the some point of time? I'm not able to finalize, but it's some point of time. Some point ahead. I'm not sure what that we have to calculate that. We'll come to calculate that in just in a while. So now what will that new index be for our right call? So right call will be from somewhere but y till the end of the this. So we have calculated our this will be the end. Wherever we want to break this, now this x and this y we have to calculate. Actually this will be this same only from new start till some point x, and then after that index till some point till end. This is what will change for our pre-order. For in order it will be very simple. For in order, the left part will be from old start till one index, and right part will be one more index plus 1 till the last. This is easy to determine the recursive call, but this part is a little tricky. The pre-order will shift by will increment by 1, but till what point I'm not sure. But wherever that point is, from one step ahead that till end of that. So we just have to talk about this x. What this x is going to be? Correct?
Yes.
Is this correct? Yes.
Yes.
So can you think what this x is going to be? Value of x? So if 5 is here, then all the left is on the right left side. All the left of this is on the right side. So can you not simply see here that what are the size of this? What are the size of this will be equal to size of this? Size of this will be equal to this. Am I correct? So my point is,
Can you repeat once?
yeah. So my point is, whenever we call recursively, the size of the in-ordered array and pre-ordered array, whatever we are using, has to be equal every time. Because
Yes.
okay. So if we are passing this to our as index of in order, can we not use this value only to calculate the index of this?
Clear.
So it will be from this start, x will be equal to from this array only, from this index plus this difference, plus this size, which is part of the plus difference of this. Is this correct? Do you see what I did? So I calculated the size of the in order, but whatever has been passed. But this is correct for sure. This is correct. I know this is what the index for the in order is going to be. Using that size, I have determined what is going to be the end index for the pre-order. So start we knew it will be start pre plus 1, but we did not do the stand. So what the end will be equal to start plus the difference. Okay, simple.
Yes.
Yeah.
Nikhil, next time kuch? Oh, you got it.
Yes, got it.
Got it. So we have our x calculated, and it will be x, and it will be x plus 1. Done.
Yes, Praveen.
Nice. So yes, that's almost. I'm almost done with the class. One assignment I have given you is find the write the code for iterative in order and iterative post order, and then last assignment is now for you. Given the post order and in order, can you determine the tree using post order and in order? It's going to be something similar, but you have to just think about the code. pseudocode, and in this case, okay, I'll write only iterative in order. You have to try to write a working code. Iterative post order, you have to write a pseudocode, and then the last part is also pseudocode. Enough assignments for today.
Yeah.
Tomorrow we'll again try to start at 9, and we'll try to do as much as possible. At least we'll try to stretch till 12 if possible. Otherwise, we'll see what we can do. Okay.
Praveen had
Okay,
sent
Praveen.
yesterday some assignments of the last week in the mail
Okay.
thread.
Okay, then let me open that and discuss if people have time. Even. Why do you save something in your .txt file?
This ID on link, I don't get it properly. So once I run it, I save it in the notepad.
Not right. At least extension should be something like .java, .rb, so that you can get highlighted thing. Anyways, so this is a reverse linked list.
Yes.
Okay, so you have written this method reverse a linked list, and you passed it a reference to node. Okay, double pointer we have used, and then you what to do is you initialize your pre, you initialize your next, and you take your current using all these three. You write a loop. Okay, so you have these three things initialized properly: your previous, your current, your next, and using those three values, you're playing with the pointers. What you say is my next will be equal to current next. So we have our next in our next, and we have changed our currents next to previous. So we have reversed the node back somewhere. So we had this linked list, and we had these pointers. So we are suppose we are currently here. This is our current node, and we have already pointed this part to old previous. Now our current is this, our previous is this. Lot of noise coming. Please make sure. Yeah, you have a current, you have previous, you have a next here every time. Now what you do is at the current, your next is equal to current next, that is here stored here next here, and you have currents next, which was this. You have deleted this part, don't want this anymore, and you have reversed this to your previous. Okay, just a second, there's something missing. This was not there. You had some part already reversed. I'll try to draw that for you. This part was already reversed. We are in a mid situation where we have reversed some part of the linked list, and we have reached a point here, and then we calculate our next equal to this. We have stored in our next variable. We deleted this pointer and pointed it to our previous, which was previous for here, hence we have pointed this. So next is equal to current next. We have stored into this. Previous is equal to next. Current next is equal to previous. Current next equal to previous pointer. We have done the change, and previous equal to current. So we have moved this previous to here. We have moved p equal to this here. And then we have also moved our current. We have also moved PNC and PNC. So now we our next is here only, but and previous is here and current here. Again, we do the same thing till we reach null. Simple code. Everyone has understood this code. We have discussed this earlier also. This is one of the simplest code, one of the simplest questions as well. And at the end, what we have to do is, what is happening? How come there's so much noise from your side? Is it just because your mic is on, or do you see some actual noise happening? The moment you switch on your mic, I think that it gets automatic. I don't think you make noise. There's some problem with the mic maybe. Okay, so this is a very simple code for a reverse linked list. And okay, so anyone who had not, at the end we reverse our head reference, whichever we passed, because that is going to be our new. Changing the value, we are changing current, and then we return. So we return this one. At the end, we'll return this node. Yes. Okay, this is done. You have submitted one more question, Suganya. What is that?
Yes, that was height balance. That is just the implementation of what we studied last week.
Okay. Then we'll just see it and
I
then
have
we'll end.
not written the driver program. I've just written the function of checking whether it is height balanced and how to calculate height.
Okay. So do you see height balance code or do you still see the old code?
Yes. Yes, I see the height balanced code.
Okay. Okay. So we have our int LH is equal to calculate height for the left, calculate height for the right, and if the absolute difference is more than equal to 1, no, this is less than equal to 1.
Yes,
Then only you call recursively for left subtree and right subtree. If both of them are height balanced, then only you if absolute of LHM RH minus is less than equal to 1, then you tell whether my left subtree is balanced or not, right subtree is balanced or not. Correct. This is okay, but you are using calculate height once. You are using calculate height once again absolute of this, and if the height difference is less than equal to 1, and then also left because yes. So what is the complexity of this implementation?
we are calculating twice.
The complexity we discussed was n square, where n is the number of nodes. We are unnecessarily calling our height every time for the same overlapping problem. So that's what we wanted to improve on. Instead of calculating height first separately and calculating height second separately, and then calling it recursively, it has been, which will in itself call height again for those. So we should be able to. That's what the solution I gave in the last class. I remember. If you do not remember, we'll try to discuss once again. We should be able to use our height balance only to calculate the height as well as determine if it is height balance or not. You should not take only one call. Right now, you're taking only one call by this method, and that call is return the false, return true or false. That's it. But instead of that, we could have written two things. One is return the true and false, as well as return the height, so that we can use that before the recursive instead of calculating again. Okay, try to think about this again. We'll discuss in next class.
Yeah,
Okay.
yeah, sure.
Okay then. Thanks. Bye bye.
Bye.
Yeah, bye.
Any question? By the way, any question? Any more question? Any query about the class? About the plan? Anything? Do you guys have any interview scheduled?
Actually, not attending now.
Not ending now. So you're waiting for this class to get over.
Yep.
Yes.
Okay. So we have done. I think this is our 8th class. I guess 8th. Is it?
Maybe.
Yes. So that is number of sessions which I have uploaded. Do you guys see the YouTube video or not?
Yes, I
Yes,
do.
practice page.
Yes.
Yeah. So this is the 8th video going to I will upload. So we have this 8th class, and we still have more 12 more classes left. So I want you to start taking interviews in my after my 12 to 13th class, so that you're ready with knowledge. I don't want you to end the class and then start taking interview. That will bore. Don't be afraid of interviews. Try to give interviews as much as possible. That will give you more learning than this studying as well. It's okay that you do not that you're not able to crack all of them. Even if you miss, that will be positive. If you crack, you'll get more confidence. If you lose, you'll get more at least. Okay, I should prepare more. It should not be a negative feeling that you're not able to crack into. But what I want is after 4 to 5 class, I would expect you people to start attending interviews and discuss interviews as well. Is that correct? Is it okay for you? Do you think that should be done, or do you want to wait till the class is over?
It should be fine.
Okay. You might face a problem that you might end up wasting interviews. Then do one thing. Try to give interview where you don't want to join only. Just give interview for the sake of learning. Okay. Practice is again practicing question yourself. Practicing question interview that's going to benefit a lot compared to any other thing. Okay. So I'll try to give a plan when I'm going to do all the class dates of all the classes. Not although we have it in our Zoom calendar, and I'll try to add the topics as well. What topic, so that you can plan your interviews. I want you people to start giving interviews so that I can see you people cracking at least one interview before I finish the class. Okay?
Okay.
Okay.
Done. Bye-bye.
Bye.